in the technology business that we could start this discussion in 1918. But I thought we would start there this morning because some of you might not know the answers to these questions. Do you know why this resort was originally located in this particular location? It was because of a ban on the import of cotton from Egypt after World War I. And the Goodyear Tire Company needed cotton for their tires, and so they moved out in the middle of a cotton field here and started using, to reduce the length of the supply chain and to get ready access to cotton. They built this resort along with an airport for their executives to fly in and out of, and a few other things that are interesting. And I'm going to tie this to the small talk world in a few minutes in ways that you would find a little entertaining, I hope. Did anybody happen to notice the shape of the windows in this resort? Yes. And do you know why they're shaped that way? It was matching the tread of the Goodyear tires in 1918. So, and of course, one of the things that they enjoy doing is having the Goodyear blimp here, actually at the airport, even in the late 1918s, so in the teens. So with that background, you're going to find that there is actually a connection in this rubber process to Smalltalk and to Objective C as we go along, but it won't be obvious for just a little while here. Would somebody turn on the projector in the back?
Yes.
Or, okay. It worked perfectly earlier, of course. So I entitled this talk "Inside the Brackets." We'll also understand what that means later on. So once upon a time, when I was working in a little company called General Electric, I got a telephone call and said, would you like to be a part of a new programming technology center to compete with Bell Laboratories that is going to be situated in the state of Connecticut, and we're going to build it from scratch. Money is no object. And so I said, well, that sounds interesting. And like becoming the first user of Smalltalk, I didn't realize that I was also the first employee of this programming technology center. So I arrived and went through personnel and so forth of a sister organization of ITT, but they hadn't decided where the office space would be, even in which city it was going to be located, even though I had moved there from Maryland to take this new job. But I was hired in late '79, and my job was to create an advanced programming technology group and to build a connection to Tektronix. One of the people that I hired there was a fellow by the name of Jack Grimes from Tektronix. I had a number of conversations. In fact, I had a competing offer with Tektronix at the same time that I went to ITT. And then I hired in people like Brad Cox and Rudy Ramsey, who was a human factors expert. We had about 24 people in this overall group. And one of the things that we did actually was to create a vision of the future. And I had, I think, in my briefcase, actually a 1981 paper that was written in April of '81 describing the integrated programming environment that we were going to create. It didn't actually mention object-oriented programming, but everything else is mentioned there. And the most interesting part of that paper was the fact that we made projections of where the technology was going in 10 years. And of course it was a software group. And it actually was quite interesting because our projections about what you could have in terms of a workstation and what it would cost 10 years out was accurate to within 10%. our estimates of what would happen with software technology were off by a decade. If we could pass this around here. Notice that it was a good flight, but the landing was a little tough. But it's interesting that we were far too optimistic about the rate of progress of software and did a good job with regards to the hardware. Then in this organization one day, Brad, who worked for me, walked in with the August issue of Byte magazine, and he said, you know, I could build a Smalltalk language preprocessor for C language in a couple of weeks if you would let me take this new 68,000 Unix computer that we had just acquired. It had just barely opened it and got it running. It was called an Onyx computer. Does anybody remember Onyx computers? We found something that not very many people know about. And so I gave him permission to pick up the computer, which weighed about 40 pounds, and take it home and work furiously for 2 weeks. And on the appointed day, and Brad was very good at estimating how long it would take him to do a job, terrible at estimating how long it would take somebody else to do the job. But he showed up 2 weeks to the day, and there was the first object-oriented extension to C language that was developed in September of '81. Then, as luck would have it, just as we were making a lot of progress, ITT made a multi-billion-dollar bet on trying to compete in the U.S. telephony marketplace, and that failed, and so they decided that they no longer needed a technology center, and they began closing down this center. But at the same time, Schlumberger and the oilfield services business was trying to build their own technology center with a heavy software influence. It was referred to by a lot of people, particularly sales guys trying to sell there, as Park East. A remarkably, it's the only company I've been in where they had a very accomplished French chef in the corporate cafeteria, and so it had there was a very high probability that all the researchers would eat in the lab each day, as contrast to going out to lunch. I was hired in, and my intention was to migrate over most, if not all, of the technologists from ITT. The first of whom was Brad, and Brad came over, and then he began to work on, from scratch, iteration number 2 of an object-oriented preprocessor for C. I ended up having the responsibility there of exploring new programming technologies, and it was a Xerox shop, if you can imagine such a thing these days. And I decided that it would be interesting to try this thing called Smalltalk 80. I mentioned the other day the interesting challenges of, it was delivered and it was operational, but there were there was nothing like a user manual or nothing like, a beginner's guide or anything else. It was just a browser, and figure it out from here. So I managed to do that somehow miraculously, thanks to quite regular calls to customer support, aka Evelyn. And then finally I reached the point I was actually making some progress with Smalltalk. But Smalltalk, had lots of commercial problems. Some of the issues were really quite remarkable. We decided that this idea of having a language that was object-oriented, but it was an extension to C language, and it was it didn't take away any of the capability of C. That was a very important constraint. And we decided to try our luck at starting a company, which was called PPI, or Productivity Products International, and later called Stepstone. And the first version of Objective-C, and it was called Objective-C by that time, was in November of 1983. And it's kind of interesting that development was done by Brad and myself in my attic in the house in Connecticut. And my favorite story is we had gone off to our very first trade show with fancy brochures that were made up with PPI and Objective-C and so forth. And we put the address of the company, which was our house, and not thinking that there was a chance in the world that somebody would drive up into the backwoods of Connecticut and sort of knock on the door. But sure enough, one Monday morning, as my wife was throwing all the clothes down from the 3 bedrooms upstairs down the front hallway, we looked outside and there was this fellow walking up to the front door that for all the world looked like Albert Einstein. I mean, he was really an amazing, he had spent a lot of time trying to, acquire exactly that look. And so here comes an Albert Einstein-looking character with a big leather briefcase up to the front door. He knocked on the door and he says, "Is this the corporate office of PPI?" And we said, "Sure, come on up to the attic." And it turned out that he was a famous Israeli scientist who actually bought a copy of Objective-C and ended up being the first international user of Objective-C thanks to the fact that we were able to move the clothes out of the front hallway fast enough to get up into the attic. And that attic was in Sandy Hook, Connecticut. Ultimately, once we raised venture capital money and we actually occupied 2 full floors of this building. And here's the connection to this resort, is this building is called the Fabric Fire Hose Factory, but it is the place where the vulcanizing process for rubber was invented in the United States. Of course, all of you know that Sandy Hook has been in the news remarkably lately, and I was actually the Jolly Green Giant of the Sandy Hook Elementary School parade for a year while my daughter actually went there, which was less than a half mile from where this office was located. Now it turns out that Objective-C is, according to one measure, there's this website that people tried to estimate how many different programming languages are being used by how many people around the planet. Objective-C is now the 3rd most used programming language on the planet, according to that website.
Behind what?
Pardon?
Behind what? What are 1 and 2?
The answer to that question, I believe, is Java and C language. Interestingly enough. It turned out that Apple was one of the very early users of Objective-C, or at least they bought a copy or 2. They didn't use it too much except to figure out how to develop other object-oriented languages themselves. Actually, I think the real value that they got was that we had developed a very strenuous set of tests to verify the accuracy of C compilers. And their C compiler was not very good at all, and so we kept reporting problems to them. And they very much appreciated the fact that we were, causing their C compiler to actually work. And the fellow that ran the QA organization was a retired ITT executive who was an MIT graduate, and he also had 3 ships shot out from under him during World War II. He was one crusty, capable, smart, energetic, retired QA manager, and he had some really interesting ideas about quality assurance, which I actually find useful still today. One of the ones that I find most interesting is he had this attitude of what you need to do in a QA organization is get the worst error out first and keep doing that until the time runs out. And that then led to the issue of how do you know that it's the worst error, and you have to spend a lot of time thinking about that. But we've actually done that a number of times over the years. He had a spectacular record. I think there was one customer of ours that had 100 users of Objective-C, and it included a class library and so forth. And in a year's time, 100 developers didn't find a single error in the software, and it was all because Don Kabelic that, that taught us how to do quality. The question?
I was going to ask what his name was.
Okay. He also had another phrase that I liked, and his example was a French tape measure, but it was the question of what is the definition of quality? And he said, a quality tool is one that gives me joy every time I use it. That was another phrase from him that I remember many times. So once upon a time, this character, Steve Jobs, actually left Apple, and they were trying to decide what technologies to use in the new company called Next. I went off to a trade show, our company went off to a trade show in Los Angeles, and a couple of engineers from Next were there, sort of inconspicuously walking around trying to figure out what technologies they might actually use. I discovered one of them who was a former Apple employee, and we had a conversation on the trade floor in Los Angeles. And as a result of that conversation, I changed my flight and flew back to Palo Alto, and ended up meeting with Jobs and company. There were maybe 8 employees of the company at that time. It was the same week that they were occupying their office in Palo Alto for the first time. After a relatively short evaluation period, Next decided to use Objective-C, and Steve Jobs and myself signed a contract. Now, here's how many of you have ever been involved in a venture capital funded company? So we're a third, if not half, of the crowd. So the original contract that I signed and Steve Jobs signed with Objective-C, much to the chagrin of everyone around, we agreed that they would only pay us $5 for every hardware device that Objective-C was running. Nowadays, it turns out, that it actually runs on quite a lot of devices. But thanks to our professional venture capital support, subsequently, that whole contract was changed, and I'll tell you about that in just a couple of minutes. So Next ended up using Objective-C for Next Step as well as OpenStep. And then, as things happened, I got acquired for a second time. I was at IBM, and things were going really smashingly well. But I got this phone call that said, "Are you happy at IBM?" And I said, "Yes." And they said, "Are you really happy at IBM?" And I said, "Yes." And they said, "Are you saying that there's no offer that you could imagine that would cause you to leave IBM?" I said, "No, I didn't say that." And so I got hired to provide adult supervision at an investment banking firm, which is this also an interesting story. I won't use all the words that were used in the investment banking world, but I arrived at Morgan Stanley in charge of all risk management and trading system software for the firm. And I left a message on the answering machine that was the standard IBM message, "Thanks for your call, I'll get back to you within 24 hours." And the first message that was left on that answering machine was, "Hello, I'm in charge of equity trading for Morgan Stanley. We haven't had a chance to meet, but if you ever take more than 15 minutes to get back in touch with me, you're fired." I said, "Oh, okay, so this is a different kind of place." Then it turns out that when I was at Morgan Stanley, this character called Steve Jobs called up and said, "I could imagine Morgan Stanley buying a whole bunch of Next workstations. Do you mind if I come by and let's have a little chat?" And so he came by and we had a little chat, including a sushi dinner. And I said, "Steve, I'm not really prepared to even entertain this discussion until you go back to StepStone," and because they were not exactly complying with the original contract. And I said, "You go back and settle up the affairs with StepStone, and then we'll talk." So a couple of weeks later, he called up and said, "Call them up and you'll find out that everything has been settled." And everything was settled with that nice little contract that I signed. in such a way that there was an amazingly small single price that Next paid to completely buy out that contract and acquire all the rights to Objective-C. A truly sad thing. Then, of course, came the reverse takeover by Next. Not everyone refers to it this way, but I think it's kind of what actually happened. Apple acquires Jobs and Next, and then Jobs and Apple adopt the Next operating system and programming language. And the rest is history. So I thought I would leave plenty of time for questions. I might even provide answers. Anybody would like to add to this history with some facts?
I have a question. I remember when Objective-C was brand new, and I saw the IC specs, and I thought, oh boy, byte arrays. It was like the Smalltalk library. You know, when you use Objective-C now, it's like object and strings are not polymorphic with arrays. And when did the next step library change happen? Going to the more black box and losing polymorphism?
Oh, chronologically, I think the answer to that question would be in the late 80s, very late 80s, 88, 89 is what I would guess that, certainly when that process started.
Was it driven by a client of theirs, or was that in-house, or do you know?
I think it was in-house, technology-driven kind of approach. There's all sorts of nice stories about the early days of object-oriented programming. I remember I was once upon a time giving a training course of object-oriented design to a bunch of Hewlett-Packard designers, and they couldn't quite figure out this object-oriented concept. And so finally, at one point in the process, I said, well, let's try something. Why don't we do an object-oriented design for this application that you're thinking about? And we'll use 3x5 index cards or some such cards. And the constraint is that you can't use any words. You can only draw pictures of the objects that we're talking about. And so we did a complete design of the system using cards, and the cards were not allowed to have any words on them at all. They could only be pictures of things. And it turned out that it actually produced a remarkably good and clean and easy to understand design, and it's proven to be a useful thing over the years. And the contrast of that is that you can use this technique to go in and evaluate object-oriented applications or systems. By just reading the class names, you can learn immense amounts of information about the quality of the design. My all-time favorite to that was when I was at IBM. There was a group of people in IBM Europe that wanted to have an insurance industry class library or framework or platform. Forget exactly how they referred to it at that time. And I was asked to come over and take a look at it. I was, show me a list of the classes, and I was looking through the list of classes, and certain names just stick with you for years and years and years, and this one stuck really well. It was and this was a Smalltalk application or framework, and the name of the class was Process Claim Form Manager Entity. And so then I asked the person that had designed this, I said, could you please draw me a picture of one of those? And I think it was she actually, stuttered quite a lot and said, no, it's really hard to imagine how I can draw a picture of a Process Claim Form Manager Entity. And I said, I don't think we're ready to ship this just yet. I think we need to do one more iteration of the design.
So what were the main things that Morgan Stanley did with object-oriented technology?
Well, Morgan Stanley was one of these places where they used any technology that the person that was hired in already knew. So they were actually, there was a group of people there that were quite adept at doing object-oriented design and development. I brought in a few others to add to that mix. But they had some very capable developers And they had some other people that were very capable of writing code, but were not very capable designers.
So, but was it operational? Was it running? Was it keeping track of money? Was it?
I mean, everything, you know, from trading to cash management. You know, I remember one project that was called Octopus, and Octopus was an application that was actually written in Smalltalk. That its goal in life was to figure out how much money Morgan Stanley either had or needed to borrow at the end of the day. And you know, at the end of the day, it would often be a number like, we need to borrow, you know, $14 billion. You know, so it was a relatively large amount of money that was, you know, moving around, you know, from a day-to-day basis. The other statistic I remember was that overnight, to do reconciliation of all the accounts, there were 3,200 programs that had to run in sequence before the start of operations the next day. Then the other thing that, you know, when I first arrived, I said, it was like 250 people working for me. I said, I'm going to sit 30 minutes with every one of you. It was New York, London, and Tokyo, and understand what you're actually doing. And I kept a little notebook, and they were actually using 32 separate procedural programming languages. And so I said to them, convince me we can't get by with 16. And
Standardizing on one.
I'm sorry?
At least you weren't standardizing on just...
No, I thought getting it down to 16 would be a hell of an advantage. You know, if you think about it from a human resource perspective, you know, you've got only 250 people with 32 different programming languages, and, you know, you've got 20 people on the bench. That was never anybody on the bench. There was always something to do, but conceptually, but they wouldn't know the right language. And then two of those languages were actually homegrown languages, the most special of which was an APL-like language called A+, that was homegrown. And for those of you that might be compiler developers in the audience, or development environment specialists, this guy had the idea, somebody had told him that if it's a compiler worth its salt, it can be done in 10 pages of code. But over the years, they added more and more functionality, so he had to get more and more creative to make it all fit on 10 pages of code. And so he got to the point where he would, you know, reduce the size of the variable names and extend the length of the line that was consumed, so that by the time I got there and actually looked at the code, it looked like a 10-page, you know, column, you know, left to right filled column of the, you know, it looked like a dump from a program. It was just absolutely impossible. And it was, you know what it was used for? It was used for every bond trade in Morgan Stanley.
Oh, Lord.
Oh, what an interesting time.
I'd like to hear about Shoulders Corp, when you started it, and what are you doing now with it? What kind of projects are you working on?
So Shoulders Corp is 17 years old in March. We got started by a phone call from a friend who actually was a customer of Objective C in Silicon Valley, and also in the investment banking software business, risk management business. He said, I don't think I'm getting my money's worth from my programmers. And I said, well, you're not the first person that's had that thought. And he said, would you come out and spend a week and, you know, look at my organization and tell me what you think I should do? So I agreed, and I came out, and Tuesday afternoon I called him up and I said, you know, we can't wait till Friday. You've got one project that is in such critical shape that you need to know about it tomorrow morning for breakfast, and then figure out what to do, because they had committed. There was a risk management company in the financial industry, risk management software, and they had committed to build an international equity risk management system that would be freely available over the internet, and it was going to be rolled out at a risk management trade show in New York, the date for which was already fixed. I said to him, you need to cancel this project and take whatever lumps as early as possible, because there's almost no chance that you'll ever be successful with this project. And he says, I'm a Silicon Valley entrepreneur. let's have a conversation about almost. And so I went through and said, well, here are all the reasons why I think you should just cancel this project, because you don't have any requirements, you don't have any definition of what needs to be built, there's no team, there's no budget, there's no design, and it's 105 calendar days for when you're going to roll this out for the public in New York to the investment banking community, and they're pretty picky customers. And he said, well, what would it take to reduce the risk and have some chance of being successful? And I said, well, give me 24 hours to make a list. And so I came back with this really long list. He said, okay, I agree to everything you've asked me to do. Would you take over the project on Monday and make this work? And I said, I'll take it over on Monday, but if I reach a point where I realize that there's no chance of being successful, I'm going to, come meet you for breakfast and, explain the news. It turned out that the following Monday we had 100 calendar days left. I put together, I actually assembled a team over the weekend, and we started work on the project, and astonishingly, and I would say really astonishing, because everybody involved in this were, astonished. On the appointed day, we rolled this out at the trade show in New York. It was covered by the Wall Street Journal. The front cover of the second section of the journal had the results of this risk view project there. And then the best part of the story was that there was IBM was one of the partners that we brought into this project, and the IBM guy that was in charge of running the website, which this is 1997, everything was just barely working. Was driving into work and listening to a local Chicago jazz radio station, and the announcer says, I just picked up today's Wall Street Journal, and there's this really interesting application that's described there called riskview.com for those of you that are sitting at your computers. And he forgot the speed limit at that point and proceeded as fast as he could to work to try to keep it. It turned out that we had 100,000 users the first week and no errors. And we had this little celebration of this team, and we thought we had witnessed a miracle. We didn't think this was something that actually could be replicated. We've actually done it 19 times since. We did change, however, the definition of 100-day project, which is a really important thing to do. We went from 100 calendar days to 100 business days. And that's an immense improvement over the whole process. But we've basically been doing, we have 3 words to describe what we've been doing: agile legacy reengineering. So we help companies with legacy systems to completely rebuild them using modern designs and tools and technologies. Most everything is in Java, actually, these days. In the last 7 years, we've been involved with electronic medical records, and that generates, enormous stories as well. Like, we were hired by the Department of Veterans Affairs to help them figure out what to do with their legacy system, electronic medical record system called Vista. And they thought they had 1.5 million lines of code. Well, it took us a while to actually find it, the code. It actually took 4 months to find the code. We found it in a horse barn in Idaho. We got our own copy, and it's all written in mumps. I don't know how many of you are mumps programmers. But this is really special mumps code because they discovered in the 1990s that it's an interpreted language, so comments actually consume machine resources. So they stripped out all the comments, and then long variable names take a little processing time too. So they used numeric variable names, like a patient's name is N347 or something creative like that. And as we measured this code, we discovered that, well, it was just a little bit larger than they had thought, actually. It was actually 15 million lines of code instead of 1.5 million. And for those of you that think in physical terms, if you printed it out and stacked it up, it's about a 15-story building of code. And if you can imagine, 15-story stack of paper with no comments, no mnemonic variable names, and no external documentation whatsoever. And then the coup de grace, you can't make up some of this stuff, right? Is it's not under configuration control. The last build from source code was done in 1996. They make 50 changes a month in each of 152 different locations in a very tightly prescribed process. And you know, the thing about that I mean, I literally spent months thinking about this and getting information. It was astonishing to me that this worked at all. You know, because I did mention that there's no regression test suite. That's also kind of important, you know. But it's just the medical system, you know, it's not like keeping track of how many pills you take a day or how many you're supposed to take. It controls the robot that goes down and fills your prescription, for example, and goes and pushes the elevator and takes you up to the, you know, the floor of the hospital. And there was a little problem on Monday morning that certain outpatients that were getting the first person each week to get their prescription filled was getting 10 times the number of pills that they were supposed to. And that was considered, you know, sort of something that should be taken care of pretty quickly. Those kinds of problems. And then you know, it turns out the largest project we've done in shoulders is actually re-engineering 11 million lines of code for payroll system. And payroll systems have their own, you know, entertainment value as well. There's two stories I like to tell. Is we found out that, you know, you have to support every business rule associated with every taxing jurisdiction in the United States and the interactions between them. And that's kind of tricky stuff. We discovered that there's a law. Is anybody from the state of Michigan or has once lived in? Okay, so there's a special law in the state of Michigan that's you're unique in this regard, from what I know, in that you cannot give a pay increase to a deceased new hire. So you can hire dead folks, and you can pay them, but you can't give them a raise as they're being wheeled through the door. Which seems like a reasonable plan, but why it's actually a legitimate rule that you have to support, I didn't quite understand. I never found that. But there are probably people from California. Anybody from California in the audience? To get a paycheck in the state of California, you have to fill out a form. And it's unique. You would always expect that California would have things that are a little different from other places. You know, there's a little field that you have to fill out in California that is labeled gender. So California is unique because they have 7 choices.
Way to go, California.
And my favorite is, given 6 other choices, you still can't decide. It turns out you have to, you know, be fluent in both, you know, geometry and the calculus to figure out what is happening in California. That's a different story. I don't actually know what time I'm supposed to stop telling stories, but anybody else have a question or a comment or add to the story?
More stories.
Steve Jobs story.
Pardon?
Steve Jobs.
Well, let me tell another one. One of the most useful tools that we have found over the years is actually a tool for managing the scope of a development project. And we call it our $22.50 miracle tool. You actually buy the supplies for this tool at Michael's Crafts stores. You go into the craft store and you buy a collection of styrofoam balls, wooden dowels, and at least 4 colors of ribbon. And what you do is, when you think you've got the design of the system that or the application that you're working on, you build a physical model of the inheritance tree of the application. And the size of the styrofoam ball is proportional to the number of methods of each class. The wooden dowels show the inheritance structure, and then the colored ribbons show the current development status of every class in the system. And so what does this end up doing? It means that at 7:30 in the morning, you have a complete project update of the current status of every class that you're developing. The second thing is, if you walk in on Monday morning and you discover that there's 32 extra styrofoam balls that have been hung off to the side, which is actually quite a common occurrence. In the software business, we like to reward people, but show up on Monday morning and have been awake for 4 hours or for 4 days and have developed this feature that nobody thought was possible. And so you have this graft of all these new classes that need to be developed and tested and documented. And so we found this little tool to be immensely useful, and we actually have used it on every project since 1997. And the way we use it is, you have everybody developing in the same room, and you hang it from the ceiling in the middle of the room, and the most junior person on the project gets the task of, at 7 o'clock every morning, to get on the configuration management system and determine the current status of every class, and tie the appropriate color ribbon around each styrofoam ball. Oh, the styrofoam balls also have the name of the class there. And we've discovered really remarkable reactions. My favorite was a chief financial officer for a company who walked in and he said, I've been in the finance department for startup software companies and technology companies all my life. This is the first project that I could actually understand what you were doing and track your progress. Because I could stand across the room and look at the number of the colored ribbons where it's been designed, coded, tested, and fully documented. And so if you have a gold ribbon around each styrofoam ball, that means that you're finished. And so you can very easily keep track of the current status of the project and most importantly, manage scope, which is the place where projects get into more trouble than anything else in my experience.
So are there any photos of any of these online anywhere?
There's some here. Not online. I don't think they're online anyplace, but we can cause that to happen in pretty short order.
Very good.
These two, that would be fascinating.
And as we have a little motto. We have a bunch of mottos that we use. One of the mottos is make interesting new mistakes in projects. And actually, Ward Cunningham has worked with me on a variety of projects. He and I were working on a project together for J.P. Morgan about 1990. And they wanted us to help them introduce object-oriented programming at J.P. Morgan and have an appropriate development handbook for all the developers at Morgan Stanley, at J.P. Morgan. And when we got there, we did the usual thing. You talk to a bunch of developers, and every one of them had a bookshelf in those days. And on that bookshelf, every one of them had the J.P. Morgan, development handbooks. And there were like 10 notebooks. And you know what is the normal, situation for such notebooks? They still have the plastic wrap around all the pages. So we never did find a programmer who had ever even broken the seal on these development handbooks. And as we thought about it, we decided that the problem was that the development handbooks were written under the assumption that everybody needs to know how to do every job on the project, which is ludicrous. What you need to know is, what did the last guy who was a QA manager for a trading system project actually discover worked and didn't work, and what might his or her recommendations be for future people performing that particular role? And so Ward had the idea, it's like what you need to do is to take a chainsaw and take this set of manuals and make a slice through it on the basis of the role. And so we started a process of doing role-based lessons learned sessions after each of these projects, so that each person doing each role was required to sit down and spend a day describing what they had found that worked well and what didn't work well. And then we didn't edit them too carefully. So, they were filled with flames. They were filled with, comments that, you wouldn't necessarily want to see on the front page of the Wall Street Journal the next day. But it was important to keep it alive, and that's, what's been
Down to the screen and that's it.
So according to my watch, we're about done. I appreciate your time and